Hi, I'm Ehsan Baharlou, Instructor of Advanced Study of Wood Proto Architecture 3.0, integrating design, computation, and materialization. This advanced study will focus on the importance of fabrication agency in timber construction. In the seminal book, 1,000 Plateaus, Gilderud and Felix Guattari mentioned it is a question of surrounding the wood, then following where it leads by connecting operations to a materiality instead of imposing a form upon a matter. The advanced research study will investigate the generative potential of material and fabrication agency in the construction of meso-scale installation at the School of Architecture. The study has three main phases. Phase 1, material system development. The proposed material system is wood with high performance and adaptation. Phase 2, computational design investigation. Phase 3, fabrication system development, which will investigate meso-scale timber structures through a series of small prototypes. Philip Ball mentioned, today, we still do not have a material that rivals wood in its subtlety of structure and property. In material system phase, students will be introduced to wood's characteristics from microscale to macroscale. In this phase, I will discuss about the wood science, wood species, hardwood and softwood, and their physical and mechanical properties, such as anisotropic and hygroscopic behaviors, to understand how designers can differentiate and proliferate these behaviors in their design. This differentiation required to integrate the rules of material behavior in a computational framework. Prior Otto mentioned the characteristic form results from the organization of matter in space, the arrangement of elements according to a number of embedded rules. In computation design phase, the students will be introduced to unique design strategy, such as generative design, or they will understand the potential of parametric design to simulate material behaviors. For example, to examine wood bending active behaviors of a parameterized module. The simulation will be validated by physical modeling and prototyping. Proto mentioned, thinking is more interesting than knowing, but less interesting than observing or looking. To observe or materialize these experiments, the students will explore limitations and capacities of digital fabrication tools such as CNC machine and robotic fabrication. Robotic fabrication methods will be taught, which include milling, routing, and assembly. In the assembly process, wood joinery systems will be discussed, and how designers can benefit from the unique technologies in their design. In addition, students will be introduced to the augmented fabrication process. They will collaborate in fabrication and assembly processes through mixed reality technologies, such as Microsoft HoloLens headset, to apply their design intention in real time. In this studio, we will focus on robotic fabrication to construct one-to-one timber structures. Here is an example from fall 2018. In Kirk, Nicholas, and Munge developed and constructed self-forming hygrosensitive tectonic. They examined and simulated hygroscopic behavior of woods to design bilaminated panels to generate self-forming mesoscale structural applications. Another example is pattern-dominant bending tectonics, developed by Tianqi, Zini, and Jing Yao in fall 2019. They investigated the mechanical behaviors of wood to integrate material and fabrication behaviors in the design process. They developed a computational simulation to differentiate a modular pattern on a free-form surface. This study will be started by an introduction to wood proto architecture, wood anatomy, manufacturing process, and wood joinery systems. Week 2 to 4, this study will be followed by a material system phase. Week 4 to 7, computation design strategies will be discussed. Week 7 to 14, robotic fabrication system will be explored to make small-scale prototypes, which will lead students to construct final mesoscale timber structures. The students will develop their project in group. The focus of this study is to understand the importance of fabrication agency in timber construction. Accordingly, 3 workshops will support this study. In computational design workshop, I will teach grasshopper add-ons related to timber construction. In addition, I will introduce students to Fusion 360 to witness the potential of integrative computational tools in design process. In robotic fabrication workshop, we will work with our new robotic facilities, 3 KUKA KR10 and 1 KUKA KR120. Each group will work on one robot to learn and complete their projects. In mixed reality workshop, students will work with HoloLens headsets. The aim of this workshop is to integrate mixed reality in design, application, and assembly of final installations. Thank you for your attention. Please feel free to contact me if you need any further information.